Okay, great. I think we're going to make a start now. So a massive warm welcome to everyone who's joined on this lovely sunny Monday morning, mid-morning. So yeah, massive welcome. So we're here for the Decarbonisation Manufacturing Inputs webinar for a really exciting talk. Lots of great speakers. So yeah, lots of interesting things to be talking about. I'm going to hand over to Rachel so she can talk about a bit about ADViCE, and then we're going to hear from our brilliant startups, and then we'll be heading into a panel. But you'll hear all about that as we continue. Over to you, Rachel.
Hi everyone. So I'm Rachel. I'm a policy and research manager at Digital Catapult, and I'm also the delivery lead for ADViCE. And I'm going to give you a quick overview of what ADViCE is about and what we're trying to achieve here. So the AI for Decarbonization Virtual Center of Excellence, or ADViCE, has a mission to accelerate the development of AI technologies for decarbonization applications to support the wider transition to net zero. And ADViCE is a program in the DESNES Net Zero Innovation Portfolio Program. And we're here to bring together an ecosystem of AI developers, industry adopters, government, policy, and regulation stakeholders, as well as academics and research centers. And we want to support, promote, and coordinate the adoption and diffusion of AI decarbonization applications for industries. At Digital Catapult, we are the lead partner for ADViCE, but we also work with Energy System Catapult and the Electronic Institute. And so we are focusing on 4 high-emitting sectors, namely agriculture, built environment, energy, and manufacturing. And these are key industrial areas that are yet not fully leveraging the usefulness of AI to decarbonize. And as ADViCE, we're looking at how AI can really be used to tackle decarbonization challenges across these 4 sectors. And as part of the ADViCE projects, Energy System Catapult has identified and defined 7 decarbonization challenges spanning across the decarbonization of homes, increasing the flexibility of energy networks, improving efficiency in factories, or even reducing pollution in agriculture. And so we focus on how AI can really play a role in reducing emissions. And you can scan the QR code here if you want to read these reports and learn more about these challenges. And similarly, we have developed a deck of virtual cards that delves into the details of these grand challenges that I've just mentioned. And we also look at the sub-challenges that sits within those grand challenges. So for each card that you have, you can read how AI can be used to decarbonize those sectors. And you can again scan this QR code or also find these cards on the ADViCE website. I will add a link later in the Zoom chat. So today we'll be talking about the 4th challenge, namely decarbonizing manufacturing inputs. So manufacturing processes are major contributors to global emissions, with heavy industries being responsible for nearly 40% of global CO2 emissions. Manufacturing processes are very fuel intensive, and the use of raw materials has also huge carbon and environmental impacts. So we have, on the one hand, fossil fuels and diesel that are still the primary energy sources for many industrial processes. And this reliance on fossil fuels is necessary to create feedstocks or raw materials. And for instance, the manufacture of aluminum, steel, or iron involve the use of very high temperatures and is therefore a very energy intensive process. And lastly, we also have the extraction of materials, which is very resource heavy. And this does not only lead to a significant generation of emissions, but it also has a very significant impacts on societies and on biodiversity. So addressing this question of decarbonizing manufacturing processes is critical if the UK wants to significantly reduce its emissions. And I will now let Cecilia introduce you to the 3 companies that will talk you through how they're addressing this challenge using AI or machine learning. Thank you.
Thanks, Rachel. Really helpful to understand that kind of overview of ADViCE and the main focus of this one on manufacturing. So yeah, we're going to hear from our 3 startups about using AI to decarbonise inputs. We first have Buffy from Carbonari. So I will hand over to you now, Buffy.
Hi, thanks. It's great to be here. So CarbonRe is an industrial AI company on a mission to reduce carbon emissions by gigatons every year through using AI technology. We're about 3 years old, and we're a joint spin out of Cambridge and UCL based here in London. We're a team of mostly software engineers and AI and ML engineers focusing on developing our software product, which is currently focusing on the cement industry, but we think we can roll out the solutions that we're applying to other foundational materials such as steel and glass, which, as Rachel's alluded to, are a major contributor to global emissions. So the reason we set up CarbonRe, for me personally, it was very much an existential driver, seeing what's happening to the planet and really wanting to develop a product that was going to have a direct impact on carbon emissions. And we also decided to go for the biggest hitter in terms of global emissions. So we know that cement is essential for modern life, and it is also responsible for 8% of global carbon emissions. And the industries themselves are facing a perfect storm of rising energy prices, low margins and growing carbon taxing, and much more pressure from political sphere to hit net zero. There is a lot of innovation happening in this space, and a lot of expectation that carbon capture and hydrogen can have a massive impact on reducing emissions in this industry. But these are a long way off scale, and there is just not a silver bullet solution that will be a toolbox approach to decarbonising these complex industries. So we believe that digitalisation is really key to ensuring that resilience and creating a pathway for these new and emerging technologies in the future, and can also have an impact on carbon emissions today. So we really want to see a shift to digitalisation and adoption of AI solutions in this industry to help hit net zero. So at CarbonRe, we wrote a white paper last year. We published it. It's called The 3 Technologies to Tackle Climate Change, clearly very much focused on cement. The approach that we took when we were looking at this paper and doing this research is that we know that we need to focus on 2030 targets for carbon emissions reduction over 2050. And it's more important to make significant impact about our climate emissions in the next, well, looking at 6 years, 5.5 years, than it'd be better to make significant progress by 2030 than to hit net zero in 2050. So we need to be acting now. We need to have solutions that are going to be driving that change. We looked at 13 technologies that are available today and identified that there are 3 that could deliver 81% of the opportunity between now and 2030. The other opportunity that these technologies can bring is that it buys us time to be developing and scaling new technologies such as carbon capture. So the 3 technologies that we identified were substitute cementitious materials, always stumble over that, and standard LC3, biomass, so using alternative fuels, and sort of underpinned by AI technology. So this is what we're doing at CarbonRe. We've developed an AI-powered, cloud-based solution, which is focusing on the fuel use in cement production. So that's about 40% of the overall emissions from cement production. The rest of it, the 60 to 70%, is coming from the calcination, the actual chemistry that happens when you heat up your raw materials. We've already identified that there is a huge variance in the amount of fossil fuels that are burnt in an existing plant. And that can vary between up to like 20%. So for the same output, the same quality, you could be burning on a good day 20% less fuel than on a bad day. So we know that opportunity for fuel use reduction is there. And our solution, being cloud-based, requires no hardware installations, no change to existing cement production processes. It extracts data from the existing infrastructure in the plant. These are really volatile, complex environments, so there are a lot of data sensor technology, and we plug our solution directly into an APC, expert control system, taking that existing data and being able to model what's happening in that environment and feed the recommendations directly into an expert system to make set point changes on a 15-minute basis. So we've shifted that process from being reactive. So currently it might take 1 to 4 hours waiting to get a lab sample back from any testing to be able to then make the decision to change some set points and adjust processes in the plant. By doing it on a 15 by 15 minute basis, we're being able to be much more agile, predict the future quality of that clinker, and reduce the amount of fossil fuels that are being burnt. So it is going to be, with a lot of AI technologies, an iterative process. We're building models on top of models, and as each time we do, we are able to push the envelope of the amount of fuels that we're burning. So today, our product is operating in 5 plants. We're expecting to expand that over the year. We're seeing about a 2% reduction with our first product, which is focusing on free lime. We've just introduced a new feature looking at O2, oxygen in the system, and that's actually almost doubling the impact that we're seeing today. So obviously, the challenge that a lot of digital technologies have is data quality, problem with sensors, and so our product is also helping to extract that data, make it meaningful, and giving an ROI for these plants that have invested a lot of time and energy and finances into Industry 4.0 initiatives, and helping them realise the opportunity that brings. So we are really focusing on increasing our CO2 impact in the cement industry. As I mentioned, we want to be building out additional features, and we think that we can push that 2 to 5% envelope that we're aiming for this year to sort of 15 to 20% reduction in cement production process. And the next 2 years, we're looking at pushing that to reliably to 8%, as then we can go out to Series A and hopefully expand the team and be able to deliver to more cement plants, but also do our exploration into adjacent industries, probably be steel or glass. And then we can further increase our emissions reduction. We know that we cannot hit our gigatons of cement CO2 reduction annually by cement alone, so we will be needing to move out into other industries. But what we're really excited about is with our technologies, we can go into those plants with existing infrastructure and make that impact in the short to medium term, and hopefully pave the way for those future technologies and enable them as well. Thank you very much.
Thanks so much, Buffy. I'm now going to hand over to Bogdan from Intelligence.
Thanks, Cecilia. Yeah, hi everyone, it's great to be part of this webinar. Today I'll be talking about the other foundation industry, which is steelmaking. So first, a bit more about Intelligence. Intelligence is a software company that we offer a machine learning platform for our customers to use. We focus on accelerating R&D through innovative design of experiments. We try and reduce our customers' experiments up to 90%, saving them cost and time for developing their new process, alloys, or formulations. The strong focus of our company is on challenging datasets. We work with sparse and noisy datasets where lots of machine learning really fails, but we apply in those very, very high challenging environments. We also focus on ease of deployment and ease of use. As I'll show you later, our platform is designed for experts in their fields that don't really know anything about machine learning. We try and allow them to apply that in their work. And as you can see, we work in a large variety of industries. We work in chemicals, materials, life sciences, food and beverages occasionally as well. And the one I'll be talking today, manufacturing process. So when we talk about decarbonising, a lot of the times that decarbonization in our cases is driven by regulations, where we try and make more greener formulations, make the process greener and keeping them safe at the same time. What we see a lot of times is, and where AI can really help, is making those businesses resilient and making them speedily react to those changes in regulations or which is set to them. And where we believe the key lies is in data, because data is your business. You can apply machine learning, learn that data, and hopefully pivot very quickly in a different direction, which satisfies those regulations. One such case is the one I've put with welding alloys group, where chromium is a very harmful for the environment material. It was regulated out in the European Union, so the company Welding Alloys had to develop a new alloy with similar performance that reduces the chromium content. This is a very challenging thing to do, so they use machine learning for their case. You can find the study case on the website if you want to read more. The one I'll talk about today is the steelmaking industry, because it's, again, foundation industry has a very high impact on the global warming and the carbon output. So I'll talk about that today. Cecilia, can I? So why the steelmaking sector? Because it accounts for 7 to 11% of the global greenhouse gas emissions, which is a massive, almost as much as the one that Buff is talking about, cement and concrete manufacturing. There's large amount of steel produced in the world, almost 2 billion tons every year, and that quantity is increasing year by year as well. And the process where we applied machine learning, which is the NISCO plant, is regarding this BOF converter. So this is a converter process which is 70% of the world of steel is manufactured through it. So I'll just want to quickly briefly mention about that process and what it actually does. So again, very briefly, what actually the aim of this study case was, increase the process efficiency. We want to reduce the time of this process. So the more that we reduce the time, the quicker the process is, the less its footprint and effect on the environment. At the same time, we wanted to increase the amount of scrap. So scrap is the recycled material. So we want to recycle more material into the process, again, reducing the environmental impact. What is a converter? Is the process highlighted in the red square. It's you can imagine it's a big cook pot where you throw a lot of ingredients, one of which is iron, which is with very high carbon amount. You throw scrap or recycled material in there. You also throw various other inputs or additives, such as limestone and other chemicals in there. So you can imagine it as a big cook pot where, well, 150, 180 ton cook pot where you decarbonize the iron to steel. So as I mentioned, it's a fairly complex process where you have a lot of manufacturing inputs, which makes it an ideal case for machine learning. At the same time, we have a lot of data. So the company provided us with years of data, which amounted to 12 million tons of steel that we had data about, and we fed that into our Alchemite platform. The analysis, or part of the analysis you see at the bottom, is this plot, which can tell you which one of those manufacturing inputs was actually the most influential for either the targets, in this case, the time or the carbon amount. As you can see, some of them were regarding how much additives, like limestone, we have put in the process, and others were how much you stir the process. So there's a stirring process, again, as any cooking process. You can imagine there's a stirring where we want, of course, reduce that stirring amount and reduce the whole process time. So that's what we can aim to do with machine learning. So the screenshot you see in front of you is our Alchemite platform. We've already created a model, but once we have a machine learning model, what we can do is go back. So we can ask the machine learning, given my requirements, in this case was the process time under 16 minutes or 1000 seconds, and carbon content, final carbon content in my steel between 0.06 and 0.08%. So these are my requirements for the process. How can I achieve them? You can ask back the machine learning model you've created, what do I need to set my parameters to be, that stirring element or those additives? What does these need to be for me to achieve that short amount of process and that quality. So this is what we can do in a platform, and similar to what Buffy mentioned, this iterative process. We iterated multiple times with this company. We discussed with their engineers. She had practices what's best as well, because we had constraints that we had to input on our platform as well, which had to be accounted for. So the outcomes of this case study is we provided our software to the engineers at Nusco, and they applied it in their work. So even just the highlighting which elements and ingredients helped the process and helped them increase the efficiency of work. We also used the optimization process to increase the amount of scrap in the material, which was one of the first goals we set out to achieve. And just after one batch, we managed to actually increase the scrap by almost 20% in the process. Of course, it took more iterations to get those uncertainties and process error down as well. We found that machine learning approach was particularly successful. We managed to apply it to multiple furnaces in that particular plant and multiple steel grades eventually as well. And this is still actually undergoing work, and they're still implementing this software and using it for further processes in the plant as well. So the case studies I mentioned were both reactive, so there were regulations instilled to the companies by government. So a lot of times what we find is decarbonization from a customer's cases is like a accompanying case or a bit more forceful, or they have to reply to those regulations. However, it doesn't need to be that way. We managed to save quite a lot of costs for this particular company by reducing again process times and increasing the scrap. So that benefit was good for the environment and reducing process costs for our customer. So thank you, and I'll pass to Jim now, please.
Great, yeah, thank you so much, Bogdan. So next we have Jim. Jim is from DigiCat, and we will hand over to Jim. Thanks so much, Bogdan.
Thank you very much. Just briefly, I'll introduce DigiCat. So DigiCat is a software services company. We're focused on AI. Almost everything we do is AI. There's a large range of what we do: computer vision, machine learning, deep learning. Most of our work is in computer vision, but increasingly, we're working on industrial use cases. And in this case, I'd like to talk to you about a project that we've done for BAE Systems. And so the problem that BAE Systems are having is that they're making large custom components. These components can vary quite a lot in size, quite a lot of variation in shape, and it takes a long time to process them. The components that are being manufactured take a lot of resources. They use custom equipment, which is very large, and the problem is that there are lots of inputs into the process. And we'd like to reduce those. But of course, it's not just the inputs that we want to optimize. The overall aim is to reduce carbon emissions. So what we're trying to do is we're trying to build a machine learning system which takes inputs, which is data from all this equipment that's being used and the resources that are being used. And we're trying to optimize that. One of the problems is that the equipment is pretty old, a couple of decades old, so it's not really set up for use with the internet. It's not really highly digitized. There was a significant data capture process at the beginning, but because it's old and big, the potential carbon savings are significant. Okay, so our plan here is to build a couple of machine learning models to predict usage of resources and carbon emissions. So the problem in itself is a variant of the knapsack problem you may have heard of. The idea is that we have a number of the idea of the knapsack problem is you have a number of knapsacks and a certain number of items that you need to fit in them, and the idea is to optimize what's the biggest number of items I can fit into the knapsacks available, which is directly analogous. We have to get a certain number of components processed by a certain amount of equipment and optimizing a couple of variables along the way. So we've got both static and dynamic data, and that comes from three sources. Firstly, there's the individual components, the kind of materials that they're made from, the geometries of those shapes. Then the equipment data itself is static as well. So that tells us about the geometry of the machine. It tells us about the other physical capabilities of it, things like the heat capacity. And then, of course, there's operational data. We want to know something about the pipeline. What's the next item that's due to be loaded into the equipment? When's it required? And what's the current status of the factory? All this data has been stored into local databases. We had to make some adaptations to the data. We'll talk about that in a moment. The data itself needs significant pre-processing. Each of these pieces of equipment has had its data recorded in lots of different ways. So there's not, the data isn't all consistent, so we need to pre-process it. And this pre-processing model was developed during the training of the models, but is actually reused in the inference pipeline as well. And on the right-hand side of the diagram there, you see we've got the two actual models, which are the important part that we trained at the beginning. Something telling us about the equipment, how should we use the equipment to minimize the two variables that we're interested in, and something that predicts the usage of resources given the inputs we've got. And there is also a simple UI. It's just a prototype of this data, so the UI is not particularly fancy, but it just allows us to display the results and input user information, please. So all machine learning problems, all AI problems really start with data. We had significant problems with data. This is ultimately a time series problem. We're trying to predict things that happen in regular sequence. But many of the data for each machine had gaps in it. And so that really kind of doesn't help your time series. The time intervals for the various parameters could vary significantly from, sometimes it was a couple of minutes, sometimes it could have been hours, different numbers of minutes, but they didn't always match. And of course, the equipment, as I've said, is pretty old, and sometimes we're getting faulty measurements from the equipment. Okay, so what do we do to overcome this? So firstly, we generated synthetic data. Where the time series contained gaps, we calculated missing values. Of course, these aren't perfect, but they allowed us to create a complete time series. Where the time intervals were different, we interpolated data, or we quantized it, so that we ended up with time series that matched. And finally, where we were getting erroneous measurements from faulty equipment, we filtered those out and replaced them, if necessary, with synthetic values, calculated values. So we've just completed the first phase of the project. So we've built our models and we've built an environment that predicts things. So we've completed that first stage. We've analysed the data in some detail. We built a training pipeline. We generated 2 models for those particular problems. We've also trained the models, as you say, and so our first version of this model has reduced both resources that we're consuming and the emissions. The mean average error for energy usage, we've managed to reduce energy by approximately 12%, And the other thing that we've done is that we've already deployed these models into the cloud. We used Azure as our cloud service, but it allows us to maintain data security. Just because it's in the cloud doesn't mean that anybody can get hold of it. We had to do our development actually in this cloud because the data was not allowed to leave the geographical area specified by BAE. The other interesting thing here is because we could put it in the cloud, we didn't have to have all our engineering teams together. Now this might seem like a small point, but we had a third stretch goal, which reduced the carbon impact of the project. And normally BAE Systems would have engineering co-located to do this kind of project. Because we were able to take advantage of the Azure cloud like this, we didn't have any travel to get people to the same location. People were able to work either from our local offices or on-site at BAE if they need to. But generally, we reduce the carbon impact of the project. So as I say, that's just the first phase of the project. During the next phase, we're going to enhance the UI that we've got from a prototype to make it usable actually on the factory floor, so that the guys making the components can actually use this on a day-to-day basis. We're going to start integrating the predictive models into the process as well. At the moment, this is still a lab project, but the next stage is to actually get this working so that it's actually used for real. But that's not the end of the project. That just gets us to a first MVP, if you like. So in the medium term, we can support a wide range of equipment. We're focused specifically on the components that are built in this factory and on the equipment that's in this factory. But there's no reason why this method cannot be extended to support a wide range of equipment. And also that the other resources are used in this process. We've focused on just a couple at this time, but we can optimize the resource usages and therefore reduce emissions in other ways. And the other thing that is kind of a high priority for us is integrating this with digital twins of the factory environment, so that we can incorporate temporal data, zonal data, so that we can map into our model. We can include a mapping of different areas of the factory. Factories tend to be older buildings, maybe not well insulated, so things like the weather can also have an impact. And really, in the very long term, we plan to integrate with the sensors and the equipment control that's actually located in the factory. That's not possible today because of the age of the equipment. A lot of it's simply not there, but that's a longer term goal. And at the same time as doing that, we've built this specifically for one factory, but in the longer term, we'd like to provide a generalized framework for optimizing manufacturing in this way. Okay, thank you very much.
Great, thanks, Tim. So now that we've had a bit more information about all the different startups, kind of what they're working on, what they've seen so far, we're going to kind of deep dive into a panel discussion. First, we just wanted to start off with a quick poll. So you'll see coming up on your screen in a minute a few questions. So it says, has your company set carbon reduction targets for 2030? Do you believe these targets are realistic? What measures is your company currently implementing to reduce carbon emissions? So this is just to give us an idea of how the audiences are interacting with this, what your current kind of pains are, what your kind of gains are, and just to give us a bit of an idea of the level of interaction. We're going to kind of go for the kind of broad spectrum of questions, and then we'll kind of narrow it down and kind of go into different areas for a bit more detail. But Buffy, if I can start with you, what do you feel are some of the main barriers to AI adoption in manufacturing that you've seen? Because I know you mentioned that you came at it from that kind of environmental stance and how can we contribute to this because of the emissions with concrete, but kind of more from a broader sense with regards to manufacturing, what are some of the main barriers that you're seeing?
Yeah, there are multiple challenges, particularly as an emerging startup in this space with a sort of relatively new technology for the industry. So, you know, slow decision making, long sales cycles. Certainly, I feel that there is an abundance of new and emerging companies like ours, and perhaps that you know, it can be a bit overwhelming for some of these companies, like which company's going to make it, which one is going to have the winning technology that they should be investing in. And given that they are, you know, long sales cycles, but they're making multi-year decisions. So actually plumping on a technology now that might not be the one that sort of, you know, the VHS versus Betamax kind of decision of the past. So I think that can be a barrier to adoption. Also, as I alluded to in my talk, I feel there's an over-reliance on the assumption that something like CCS is going to become ubiquitous, affordable, and available at scale, and actually overlooking some of the interim solutions that also can pave the way to those technologies as well. The key thing for us as a company is digital readiness, the biggest challenge. Rockwell Automation actually did some research and showed that 60% of cement plants had yet to adopt a single digitalization initiative. So while I said, you know, there are lots of companies, industry leaders that, you know, Holcim, Heidelberg, OYAC doing really well, and lots of them are using expert systems that might be Siemens, ABB, FL Smith. So there has been a lot of effort in adopting that sense of technology. Not all of them are in the cloud, and even if they do have the technology, they are collecting the data. Is it aligned to the FAIR principles? Is it findable, accessible, interoperable, and repeatable? So I think that for us, that is the biggest blocker. We've done a lot of work on building models to clean data when it comes in. So that is the biggest challenge for us as an AI company.
And Jim, you mentioned kind of one of the biggest things when you're starting a project is that kind of data barrier. What are some of the main barriers that you see?
So data is the single biggest problem, particularly given that manufacturing plants are not necessarily the most sophisticated places in the world. They could be quite old. With our project there, we had a big problem collecting data. It's not just that it's not available. There's no devices. If there are devices there, there'll be old-fashioned analog things. Somebody will have to go around with a clipboard and write data down or type into a machine. So the whole environment is not necessarily set up for doing this. And we've seen that across other factories where we've got involved as well. I would also agree with what Buffy said about the conservative nature of these organizations. They know what they're doing. They've been making this stuff for years. It's really difficult to get these companies to just switch into the new world. Some of the things that we wanted to do, connecting to sensors and building those into our models really early on, just wasn't going to fly. There's an awful lot of resistance to that level of change, which is why we're doing it step by step.
And Bogdan, you kind of spoke very briefly about regulation. How does that interact with how the barriers are affecting people within manufacturing companies?
It certainly actually helps because a lot of companies and some of our active customers are looking for solutions around how do they solve that challenge where they have to suddenly change the product, change a core product they've been selling or working with for 10 or so years. And certainly when regulations come in and they have to pivot, very, very quickly, they're looking for solutions to do that. And machine learning AI is definitely viable to do that and help them in that process. I'll say other challenges particularly is the understanding and how much trustworthiness, how much they trust it. We've definitely had to do a lot of education around machine learning. Every time we speak with a new potential customer, a new prospect, we have to do a lot of education. We have to kind of convincing even, just that it would justify the return of the ROI, the return on investment. And after that, those kind of worries has been addressed. The next one is data readiness, as Buffy and Jim mentioned. If the data is ready, then we can very quickly proceed to applying machine learning. If it's not, then it takes quite a while to get there.
And what are some of the techniques that you would use when you're talking to an organization with regards to kind of promoting data trustworthiness and data literacy?
Personally, we have a lot of analytics. So we even offer a lot of prospects to send us a bit of data, can be obfuscated, can be hidden, but just send us something, like a sample, and we can apply machine learning and we can share the analytics. And once they see that kind of what decisions the machine learning has taken when we apply it, they're like, oh, okay, we understand, these decisions is what we take on a daily basis. And that's kind of the first step, the very important step that we take with them.
And for an organization like BAE, Jim, how were you getting, because obviously that's a huge organization, how were you kind of promoting data trustworthiness, data literacy within that project?
So our general our general principle and way of working is that before we start any project, we always, much as Bogdan was saying, we like to take a look at the data that our customers have got, and so that we can have a view of whether we think it's possible to do what they're thinking of or not. And so we will always do an initial data review and give our customers a feeling for what's possible or not. And where possible, we may build a very quick demonstrator, which will take us a couple of days. And that really gives people a feeling for what is and isn't possible, and feeling what the output might look like. The other difficulty is that people don't always recognize what data is. Sometimes they think they've got data and they haven't, and sometimes they've got useful data and they don't realize it. So I remember talking to an insurance company a couple of years ago, and they had lots and lots of forms which they'd scanned in, and that became data, and they just didn't realize. So exactly as Bogdan says, it's something of a journey to educate, inform, and build things to show and tell is good. Yeah, I think that's really it.
Yeah. And Buffy, we're talking about some of the kind of critical challenges. For you as an organization, what are some of the critical challenges that you're facing?
As a young company, I mean, it's often it's finances. So to hire the talent that we need to be able to develop these models. So we are competing against, Google, DeepMind, Meta, who can have, pay very competitively. We are a London-based company. So attracting and being able to afford that talent and the development of the models, it requires a lot of upfront R&D. Been lucky in the UK, we're very good at R&D. The tax claim and grant funding really help that, but it is not enough. So we did go out to investment funding round really early on, and that means you can spend 2 years developing a product before you're actually going out into market and getting any revenue at all. So that's a major challenge, just having enough money to survive, to be able to go out to market and prove your product market fit and the impact that you can have. We've been very lucky in that respect in terms of working with industries, with plants that have been helping us co-develop products. So at least we are developing our product in collaboration with real plant data in a live environment. And then the other challenge for us is, you've got the money to hire people, but the skill sets that we're looking for, there are a lot of people working in computer vision and natural language processing, but we are looking at people who need to have an interest and to work in cement and manufacturing, and that's basic chemistry and physics understanding. So it's a unique skill set. I think we've been very lucky because we are a mission-driven company, so we're able to attract away some of that talent that might have gone working in ad optimization, that actually want to see sort of a climate impact for their work. But yeah, finances and skills are a real headache for any startup, I think.
Bogdan, can you kind of echo some of those feelings as well?
Some of them, part of the young talent hired, I guess. It's the echo that one. I'll say the biggest challenge for us at the moment as a company is the actually cultural change. So we have quite a few acting customers, and we have been around for 7 years now, almost 8 years. So we have a few acting customers, but a lot of people we end up working research and development. So people they're excited about the science, they want to learn about it, they want to apply. And it kind of stops there at the moment. We want to work more with engineers and actually chemists, people in the lab, and provide them with the software to use it directly there. That's our goal as a software company. And it's very sort of what we find challenging is that cultural change. People still want to use the old tools, old statistics, old whatever they've learned at the university, and doing that change from just applying the software to research, from research to actually in a plant or in a lab. This is being particularly challenging in the last couple of years.
So the cultural change within an organization when you're working with them. Yeah. So you've gone over that barrier of the data, and then you've got the next kind of hurdle, which is that kind of cultural change, mindset shift.
Exactly.
Yeah, that's really interesting. I suppose, Jim, we kind of alluded to cross-disciplinary as Buffy and Bogdan were saying about kind of chemists and physicists and stuff like that. With regards to the technical kind of side of things, AI is kind of one technology that can support decarbonisation. How does it work in tandem with some of the other technological tools that you've been using?
So there's a couple of things to think about here. Firstly, to build a little bit on what Bogdan and Buffy were saying, there's just within the software angle, there's a really important thing. A lot of machine learning and AI is really research driven at the moment, and research tends to be done in a more, let's say, ad hoc way. Whereas when you're building products that go into things like cars or medical or any safety critical environment, you need to apply some process. And the software world has been using software engineering processes for a long time to give some level of quality and reproducibility. Taking machine learning research from that kind of research environment into a production environment these software engineering skills are really important, and they're not always prevalent amongst that kind of community. So that's a really important technical skill that I feel we need more of in the AI world, but it's coming. It's also interesting to think about technology-wise how we integrate with IoT solutions. For example, there's lots of data generated by sensors. There's of all sorts. I mean, we just looked at a couple in our project, but there are dozens of sensors in your average factory, dozens of types of sensor rather. But then you need to integrate that. Those are integrated with some cloud, and there are lots of IoT clouds. So I guess the message is there's lots of data sources, there's lots of platforms, but there's still quite a lot of fragmentation.
Yeah. Buffy, did you want to add on that at all?
Not meaningfully, no.
No, that's fine. No, that's fine. So if you wanted to give a kind of encouraging message to large manufacturing and industrial companies about leveraging AI, what would you say to them?
I think there's huge there's huge advantages. I mentioned in my presentation that today we can say sort of 2% reduction working with the cement plants. And the ROI on that, we work with them when we're doing the modelling. We look at the historical data and estimate how much we can save and how much that would translate into fuel costs. And generally, this is going to be a multi-year project. They'll be paying back that in the first 6 months of running with our software. But also the opportunity, the insights that data is going to have. Not only are we building new models and features that we'll be adding on whilst working in the plant, the insights that we don't know are going to provide us like new opportunities, further areas exploration are really key. As what's been really interesting for us, I think Bogdan mentioned this about the trustworthy and how you get that buy-in early on. We assumed that it would be key to keep a human in the loop. They wouldn't trust our technology, and we very quickly. So we created a dashboard recommender. So the plant operator would see some set point recommendations, and then they would manually put them in. And very quickly they're going, like, our world is really complicated. We're having to deal with more alternative fuels that be really varied. That's driving much more complexity into the system. So the plant operator, like, we want something that's going to make our life easier, and seeing that opportunity from the AI solutions as well. So there's the immediate results, there's the roadmap, but also the unknown advantages and insights that we'll learn over time. And taking that, it's a risk, but taking those steps could be really exciting and quite transformative.
Bogdan, what about you?
I would reflect part of what Buffett was just talking about. It's making life easier. So AI is a tool. AI, especially machine learning part and the design of experiments part, is well understood. It's still researched, but well understood. It's fairly transparent, although I know you probably disagree with me. So it's just another tool in the toolbox of engineers and chemists that they can utilize, especially if companies have challenges, such as the regulatory challenges I mentioned, or challenges where the research R&D cycle is years and it's very costly. There's definitely can justify the use of machine learning in those applications. And that's what we see. People are interested in that, and people do believe that it can help them. So.
Yeah, Jim?
I'd agree with everything Buffy and Bogdan have said. There's a lot of benefits to be had in manufacturing. Well, there's lots of use cases there, lots of benefits for everybody. Manufacturing is particularly good. Like I say, there's like I said earlier, show and tell is always good. The popularity of lots of things at the moment. So ChatGPT is not one that I really want to talk about here, but the popularity of that has put that into everybody's consciousness and thinking of other use cases around that. And that's great. Now people are beginning to get some idea of the kind of things that are available with this sort of technology. The downside, of course, is that it's not as simple as ChatGPT makes it sound. So it's there are great benefits for everybody, lots of use cases, and that's really where it comes alive. But I think there's a way to go yet.
Yeah.
I can agree with Jim's point about ChatGPT more. Actually, just laughing at that. I mean, it has opened doors for us. It has, exactly as Jim said, it's in the public consciousness now, and it's sort of, I think there's been a lot of fear about what, there are lots of social damage that AI systems can do, but also incredible advances and advantages. And yeah, the ChatGPT discussion has just brought that discussion to the fore. And it has, I think, opened doors for us more in the last sort of, really seen a shift in the last sort of 12 to 18 months in that appetite to adopt AI and see that it can have some really exciting benefits.
Yeah, that kind of leads me on to that. The question before we went into Q&A was like saying we can't leave without speaking about the buzz of generative AI. So what are your thoughts about it in this space?
Well, for us, I mean, we don't use it at all. We're using a very different type of AI. I mean, it does help with with the day job, like the team all have access to ChatGPT-4. It helps, it's a brilliant resource. Also, just often it's like the skeleton, you know, writing a briefing note or something like that, and actually helping to speed up those processes. We're using a very, very different type of predictive learning, machine learning, bit of deep reinforcement learning. So it's a very different space. I think there needs to be much more education about the different types and use cases for artificial intelligence beyond that sort of umbrella term. And another challenge we always get from investors and people interested in climate change is, but what about the compute costs of developing these models? Now, because we're not doing large language models, we're not processing, you know, high resolution visual data. It's actually very, very low impact in terms of compute costs, and mostly we can do it from a laptop. We're not even using data centers at the moment, and obviously we go global, we hit, you know, the hundreds of cement plants that we want to be in. There's gonna be a cost, but it'd be so like dwarfed by the impact that we can have. But there is like, you know, there's the grouping together of the different types of AI does sort of muddy the picture as well as you know, highlight its opportunities.
Yeah. And just quickly, Bogdan and Jim, if you go first, what are you seeing with regards to generative AI in this space?
So a bit like Buffy, it doesn't have a major impact on our work day to day. Where we do use some generative AI is for the creation of synthetic data for computer vision models. That can be very helpful, but it's kind of a bit of a side issue rather than the main thing. LLMs are becoming more important, but the sense that they're more important is I spend a lot of time working with AI on edge devices, so pushing things out to run on small bits of embedded kit. So we are increasingly doing work with LLMs, but where we're doing that, what we're trying to do is put models onto edge devices for very specific use cases. Hasn't particularly come into manufacturing or our industrial work in general yet. I mean, it's big for awareness, but the majority of our work doesn't really use it that much.
Yeah. And Bogdan?
Yep, certainly using ChatGPT for personal work, although have to be very, very careful with what kind of work because we are not allowed to share anything, any code or any data or anything like that on there. So very, very careful using it for personal work. Other than that, I'll say we have explored elements for applications in our software, but most of those have been educational, where you can give it data, or you can give it image or something, and it will tell you more about that rather than science directly. It's not so a lot of the benefits of machine learning and the one we use for design of experiments is they give you certainties, you know, it can quantify the answers, it can give exactly the decisions it has and how it made them. LLMs can't quite do that yet, not yet, maybe in a couple of years' time. So we don't see its application in science, not yet, but definitely also for education, definitely to learn more and get points across.
Nice, yeah. So kind of definitely on a kind of personal level, and then at various degrees across, within your products, within organizations. I am going to open it up now for questions from the audience. So please submit any questions you have through the question tool on Zoom, and I will kick off with one question. So, to all of you, could anyone provide an indication of a typical timeline for delivering an AI machine learning project? Are we talking months, quarters, half years?
I can start on that one. Really depends on your data readiness. If your data is ready and you can start now, our minimum is 3 months. So that takes the whole process of familiarizing with software, familiarizing with machine learning, applying it, learning the results, and doing a couple cycles. So machine learning is very cyclic in nature. You have to do a couple of rounds, potential experiments, a couple of rounds of models, and that takes at least 3 months. Some projects where data is not ready, where the NISCO one I talked about, there's a manufacturing one where its data is, as Jim was saying, everywhere. Britain even takes at least 2 years. That very, very not digitalized environment yet. So more than 2 years, I'd say.
I would echo that. I'm very, similar, sort of the three months space at the moment. The biggest delays are, it's the negotiations, it's the trials, it's the the signing the contract to getting the data, getting our hands on the data in the first place, which can, these sales cycles are sort of 12 to 18 months. But the actual products, yeah, we can be deploying quite quickly, then iterating the models. We're talking about sort of a three months time frame at the moment. We're driving that down as we see more and more familiar environments, and we're not having to do so much model development. So there's always going to be an element of bespoke customization because the idiosyncrasies of the plant and the driving needs. I think we touched on this earlier of why are they buying our software? Are they focused on reducing carbon emissions? Are they more focused on improving quality, or they've got some other challenges in the plant that they're trying to correct for that our software can also benefit? So there's going to be some level of adaptation, but as we see more and more familiar environments, we really want to be driving down that implementation time. But yeah, still I think 3 months seems about reasonable.
And just to complete the set, I'm going to agree with Buffy and Bob. It's almost become a joke with the sales guys. What's your estimate, Jim? 3 months. But we do try to approach things slightly differently. So I think it's important. And I'm guessing that Buffy and Bogdan will both do something similar. Our first phase will generally be what we call a proof of concept. So you will just take a data set and you'll train a model, and you won't worry about any of the software problems really. So you won't necessarily worry about building a UI or deploying it in the cloud. It's just, can we make a model that works? Then we'll worry about deployment issues later. And the other thing that I just wanted to kind of reiterate is that even if we get something that's working in that kind of 3 to 6 months timeline, it's likely that you'll have to be training the model and continually making updates for a year, 2 years, depending on the precise project. Data has a habit of models have a habit of drifting in their accuracy as the data environment around them changes. So regular updates to the models can be required. So they can we've had projects run for 2 years, 3 years.
Yeah, model drift is a big one, isn't it? Yeah, definitely. So for Digicare, did you need to add sensors, or did you just use what was available? Yeah.
So we it's BAE's factory. We couldn't just go in and add sensors. So we could only use what was available. And what was available was a big mishmash of things. So in some cases there were real sensors, but they weren't necessarily connected to anything. In other cases, we relied on people with clipboards going around and reading the dials on the sides of machines. So it was a bit of a mixture, and that really was the big challenge, was a diverse set of data and methods of gathering data, trying to pre-process that into a meaningful data set on which we could train models. So it was a combination is the answer.
Okay, great. For all of you, last one, have you deployed multiple models on the edge devices is what it's asked?
I guess I can carry on with that one, because the short answer is yes. That's what I spend most of my time working on. My background before I became CTO was I was an embedded developer, so this is where my interest is. We're running projects putting LLMs on edge devices and all sorts of sensors all over the place. So yeah, the edge is the way it's going because we want to push processing out to the edge.
Great, thank you very much. Yeah, Buffy.
Yes, as well.
I couldn't.
Yeah, go for it. Love it.
possibly answer this question. My level of knowledge, so I'd defer that to my CTO or head of engineering. Get out.
I'll say yes as well, although in our case, more of an ensemble of models, mesh devices that have the same goal. We haven't quite done multiple models that do completely different things. Most of them use the exact same standards to achieve the same goal. So yes, and unassembled models on mesh devices for our case.
Great, brilliant. Well, that comes to the end of our questions. Was there anything that anyone wanted to kind of raise before? Anything that we haven't spoken about that's kind of top of your mind?
Well, I think I said my sort of parting comment is there is so much opportunity for decarbonisation with digitalisation, and obviously leaning on that the artificial intelligence, and either as a company to prepare for the opportunity, install those sensors, get digitally ready, clean up your data, make those digital strategies now. It's going to come. It's going to don't be a laggard. Don't be left behind. And like I mentioned, Holcim, Heidelberg, OIAC, these companies that are embracing it are going to be leaps and bounds ahead. So that really take a real clear look at your infrastructure as a company, and think about what is your digitalization framework look like today, and where could it go, and when could you be adopting these technologies if it's not today. And then from the real decarbonisation perspective, certainly no process is not going to be improved by being more efficient, but when we're looking at sort of 8% of global greenhouse gas emissions coming from one industry, the 2 to 5 to 8% reductions in that space is massive on a global scale, and we really should be pushing in that direction, particularly while we're waiting for plentiful renewable resource energy and battery storage and CCS and things like that. So I think I'm a big advocate, and it has a huge impact, a huge opportunity to drive decarbonisation at scale.
Great. Jim, do you have any closing positive words for the people?
Yes, well, I hope so. So we've talked about some great examples today, which are based on machine learning, but I think it's really important to think about how AI can help decarbonise it, well, help manufacturing, help industry in different ways, but also using different technologies and attacking decarbonisation indirectly. So I said earlier on that we do a lot of work with computer vision, and that's not obvious how that can help. But if you're using cameras and computer vision to monitor a production line, there's less wastage. If you find problems on the production line earlier using techniques like computer vision, and wastage is therefore reduced, you've used less resources, you've made fewer emissions. But it goes further than that. We've built systems for monitoring warehousing and stock rooms. And if you know where all your stock is, you can perhaps optimize your warehousing needs more. So you're reducing the amount of space you need, resources, and carbon emissions. So I think there's lots of opportunities for AI in lots of ways in manufacturing, but decarbonisation is particularly an important area.
So lots and lots of cost-saving opportunities, definitely. And Bogdan, if you...
Yeah, well, similar to Jim, actually, I think people just need to think a bit more about how they can incorporate those goals into what they already do. And if they're already using machine learning, or think about using machine learning to improve the product, or to save them time, or run the experiment, or run less experiments, all of that they can add in the reducing the environmental impact of the product or alloys or formulations. It could be a accompanying goal of everything they do, especially once they gather data, the data is there. It's very easy to build the model and add that feature in, and start improving. Well, start caring about the environment as well with the products.
Great. Well, thank you so much, all of you, for taking part. It was really insightful to hear about all the different kind of advances that you're making within your organisations and across the manufacturing industry. So thank you very much for that. I will now hand over to Rachel just to finish up.
Wonderful. Thanks. Yeah, so as you may have understood from this session, ADViCE is all about bringing people currently in the AI for decarbonization space together to share ideas, create collaborations and engagement. And as part of this ambition, we are launching the Data Science Sharing Circles, which are monthly knowledge sharing sessions involving AI practitioners and data scientists. They meet online for once a month and they get the opportunity to share learnings and best practices on the applications of AI for decarbonization across and within our sectors of interest, so agriculture, manufacturing, built environments, and energy. So if you want to take part in one of these, please reach out to the ADViCE team in the email that I inserted in the chat a few minutes ago. And we have also recently launched the ADViCE Expert Working Group, which involves different actors acting in this space, including AI developers and startups, regulatory bodies, academics, investors, and infrastructure representatives. And Buffy, who's on the webinar right now, is also part of this group. And so we meet once every 2 months to build insights around the current opportunities and challenges in the adoption of AI solutions for decarbonization. And we're looking at policy, regulation, public and private investments, as well as data accessibility and security on that matter. And this expert working group will be used to design future interventions and policy formulation in the space for DESNES. So if you are an industry business looking to decarbonize through AI, or if you're an AI company building manufacturing solutions to decarbonize, or if you're just an actor in the space that you want to engage with other actors, you can get in contact with us with the email that I put in the chat. You can also register interest and join as well our discussion forum on the ADViCE website to keep this conversation about AI for net zero going. And you can also sign up to our next webinar organized by Energy System Catapult, and it's taking place in June. And it will be addressing unlocking domestic decarbonization. So yeah, thank you everyone for joining this great session. Yes, thank you very much.
Great, thank you so much, Rachel. Thank you everybody for joining. We hope you have a great day, and please do get in contact if you have any more questions. Thank you for your time.